All right, here we go to section 3.2, angles and parallel lines. So now we're going to take those definitions that we just worked with in section 3.1, and now we're going to apply them a little bit here. So the first thing, let's review those definitions that we talked about. So the first thing we want to know, name the following pairs of angles. So alternate interior. So again, this is memorization of definitions, being able to apply. Alternate interior. So in this case, angle 2 and angle 6 are alternate interiors. Alternate interiors. Alternate exterior. Alternate exterior example would be angle 1 and angle 5. So again, they're on the exterior and they go across the transversal. Corresponding represents the same location in the cluster. So an example for corresponding, I could use angle 3 and angle 1. They're in what I consider the upper left of our cluster, angle 1 and angle 3. Consecutive interiors here, again, interior angles, I would say, in this case, angle 2 and angle 3. Now, all these have other pairs, but I just wanted to give you a quick little example and a review of what we learned from 3.1. We're going to apply here with section 3.2. Got a couple things to read through first. Summary. If two parallel lines are cut by transversal, then alternate interior, so alternate interior, alternate exterior, and corresponding angles are congruent. So that's a memorization point here. Consecutive interior angles are supplementary. So again, in terms of mathematics, supplementary means that they add up to 180. So just kind of a summary here, and then this slide is a little bit more confusing, so that's why I did the summary first, and then this part second to kind of just write it all out and see what it's like. So corresponding angles, this gives you a visual, see what it's like. Corresponding angles, two parallel lines cut by a transversal. Each pair of corresponding angles is congruent. So one is congruent, angle 1 is congruent to angle 5. I would consider them in the upper left of the cluster. Alternate interior angles. Alternate interior angles are congruent. So that would be angle 3 and angle 6, angle 4 and angle 5. Alternate exteriors are also congruent. So that'd be 1 is congruent to 8 and 2 is congruent to 7. This right here is a supplement theorem here with consecutive angles, so consecutive interiors. So 3 and 5, they're on the same side of the transversal. And I mean, you don't always go by looks, but this angle and this angle, you know, there's a big difference between them because they add up to 180. Also, 4 and angle 6 add up to 180. Now, when we talk about perpendicular lines, now we bring in a new thought process. Perpendicular transversal theorem. In a plane, if a line is perpendicular to one of the parallel lines, then it is perpendicular to the other. So a couple different terms. First of all, line L and line M are parallel. So we would have to give you that they're parallel. So parallel lines, if one of them, so you can see the right angle right here, so angle K is perpendicular to L, therefore it is also perpendicular to M, and so that just tells you that we have the same concept going on with both lines. So now we're going to apply what we just learned and then try to find some mathematics for these angles. Now when I am approaching these types of problems, I don't always look to see what they're looking for. I like to fill all of the angles in. So in the figure, so x is parallel to y, so two parallel lines. They're cut by transversal z. So angle 11 is 51. So I'm going to look and see how many angles that I know are 51. So what did we learn today? So angle 51, or angle 11, and what other angles are 51? So we can say angle 15, y, what vocab term? Corresponding, they're in the same location. So this is 51. You can say now the angle 12. Angle 12 is also 51. They're alternate interior angles. And once we know angle 11, we also know angle 16 because they're alternate exterior. All of these angles are 51. All those angles are 51. Well, let's say we wanted to find the other angles. let's say we wanted to find the others. Well, we have to realize that we have supplementary angles. So we're going to go 180 minus the 51. That gives us 129. And all the other angles are going to be 129. 129, all four of those. So when I approach the problem like this, I like to find all the angles. So therefore, if I am ever asked those questions, that I am ready to go to solve those. Same thing here on this slide, same concept. So we have, first of all, you want to recognize what lines are parallel. Because again, our definition is parallel lines cut by a transversal. Because you have four different clusters, four different groups of four angles. So you have to know which groups are related together. So here's a parallel, two parallel lines cut by, this is a transversal right here. So this is a transversal. So that means this cluster is going to be related to this cluster. Again, two parallel lines cut by a transversal. It's not going to be going down, it's going to be going across. So when I look and see what do they give us in the given, they give us angle 3 is 110. So this is 110. So I'm going to try to find all the angles in these clusters that are 110. So first of all, vertical angles. Angle 3 and angle 8 are vertical angles, so those are all 110. I also want to now go to the cluster over here. So angle 3 and angle 1 are the same because they're corresponding angles. They're also 110. And also angle 6 is 110. So I found four of those angles already. Now I want to find the angles in the rest of the cluster. So I want to go 180 minus the 110. That gives me 70. So all the rest of these angles in the cluster are 70. So I'm done with that group. So now I want to go to the other two clusters, and I want to use the angle 12 is 55. So angle 12, this is 55. So let's find all of the angles that are 55. Well, 12 and 15 are vertical, so they're both 55. 12 and, let's go with 12 and 13. They're alternate exterior, they're 55. 13 and 10 are vertical, those are 55. So now I want to find the rest of them, so I'm going to go 180 minus 55, and that's 125. So I know that all the rest of the angles in this cluster, 125. So therefore, I can now look at the problem, and I know I have answered I found every single angle in all the clusters. So I will now be able to answer the questions above. Okay, the next concept here is a little bit more challenging because you are given a concept, and then you actually have to create another line. So it says find the measure of angle RTV. So they actually want us to find this right here. And that's really challenging to do because we actually need a line here. We need to draw a line. Whoops, and this board's off a little bit. So we need to draw a line here. So we just created another parallel line. So this line is parallel with M and parallel with P. So you might say, well, how did that help us? Okay, that's going to help us because we're now going to use our concept of our angles to kind of get us an idea of where we're at. So I'm going to actually make this a little bit bigger over here. Okay, so this is our T, and this is our S. So we are given that this is 60 degrees. This is 60 degrees. We want to find this section because that's half of what not half, but that's part of the big angle right here that we want to find. So what do we know about the relationship between this angle and this angle? Well, vocab terms, alternate interior and alternate interior angles are congruent. So we know that this section or part is 60. So when we're trying to find that whole big angle, we know so far that part is 60. So now we can do the same thing below. Let's kind of extend this line a little bit down here. So this is U, and we still have the T. So let's extend that a little bit right here. We know this one's 65. What do we know about this angle right here? Well, that angle with this angle, again, our vocab term, alternate interior are congruent. These two are going to be equal, so that's 65. So what are we going to do to find our answer? We're going to add 60 plus 65. That's going to give us 125. So we found our angle to be 125 degrees. Next question here, same type of an idea. Let me extend it a little bit here. So in this specific example, we want to do the same thing. So we want to draw a parallel line to help us to get to where we want to be, here. So if we kind of extend that blue line over here, and we were to go up here with that, we want to find angle GHI. So we ultimately want to find this angle right here. We're going to find this angle. I'm actually going to change this, and I'm going to move 70. I'm going to move 70 to be right here. I'm going to move 70 to be right there. So 40, so this is E, and this is the new section that we just created, that new point there. And so this is 40. We want to find this angle. So what is this angle in relation to this angle? Yep, you got it, alternate interior. So this section is 40. Now I just changed this angle over here. So now let's throw that in and see what happens there. So this is F. And we're going to connect those, and we know right here, I just changed it. So F is 70. So what is the relationship between this angle? Whoops, let me just make it a big dot. And this angle, what are those two angles? So, well, those two angles are called consecutive interiors. And what do we know about consecutive interiors? Or supplementary. So we're going to go 180 minus 70 gives us 110. So this section right here is 110. So if that's 110, this section right here is 40. We're going to add these two together, and we're going to find that 110 plus 40 equals 150 degree angle. 150 degree angle. So again, with these types of problems, you have to create another parallel line to help us out. That is the end of section 3.2a. Great job.